C.4, examples on optimality. At this point, I'd like to give you a few examples to help you understand some concepts. The first one about optimality. So this is an important concept. So I would like to use two simple examples to explain a little deeper meaning. The first example, look at this one. Question: no algorithm can be optimal because one can always improve a given algorithm. Look at this statement. Think about it. If this statement is true or false, no algorithm can be claimed optimal. Why? Because how can you say this algorithm cannot be improved, right? Is there still a room to improve this algorithm? Yeah. First, the answer is false. An algorithm can be optimal. And we can prove it cannot be improved. It's possible. We can prove no one can improve it, no matter what. Okay? Even in future many generations, nobody can improve it. We can do it. Actually, we did it. Right? Actually, we did it. To answer this question, we use a simple way to answer. To say this statement is false, we use a commonly used method, counterexample. Counterexample. You just find the concrete example to show it is false. That's it. We just did it in the previous video. Remember our problem number 3. Find the minimum of an array. Yeah, I'll just write find the minimum. Okay. In that one, we proved we can use n-1 comparisons and it is optimal, and nobody can do better than that. Nobody can improve it even by one comparison. Nobody can use n-2 comparison to get the minimum, and it is always correct. It is always the minimum. It's not sometimes minimum, sometimes not. You cannot say that. It must be 100% minimum. Nobody can do that using even n-2 comparisons. So that's why our algorithm is optimal. So this is a counterexample. We find it. That's enough. One counterexample is enough to disapprove a statement, to disapprove that false statement. That's it. Okay? Yeah. So here you can see in your mind, if you collect several examples, because sometimes you need to use them as counter examples. So that's important. Here, our problem number 3, very important. The one we use it to disprove this statement. All right, so that's the first example. The second example, example number 2, another about optimality. So we try to understand this concept better. What's that? Nobody can show that certain algorithm is optimal. Why? The reason, you need to give some reason. because you cannot exhaust all the algorithms for solving a particular problem. That's the whole statement. All right, true or false? Think about yourself a little bit. Then listen to my explanation. Okay, yeah. So let me read it again. Okay, nobody can show that certain algorithm is optimal because you cannot exhaust all the algorithms for solving a particular problem. If you cannot exhaust, how can you show that an algorithm is optimal, right? So in other words, how can you show your algorithm beats all other algorithms in performance, in efficiency, without exhausting all other algorithms? That's the logic behind this statement. Okay? It sounds reasonable, right? It sounds reasonable. First, let me tell you the answer, then I explain it. Answer is still false. Answer is still false. All right? Yeah. The first explanation, some of you can use this example, right? Because we can show it is optimal. We do not need to exhaust all the possible algorithms, but we can still show. That's the first. But I also want to explain the reason from another angle. Not from this, this one is perfect, okay? No problem, no problem. But still, if you just only use this example, so you have a question. So the question is, how can you argue against this statement directly, right? Yeah. So I believe many of you like to argue against this statement directly, not just use that example. Okay? So that example, we know it is true, it is correct. So now let me argue against this statement directly. Okay. All right, so first, it looks like the logic sounds good, right? The logic sounds good. So let me repeat that logic. The logic sounds good, but actually not. The logic is not correct, incorrect. It sounds correct, but actually it is incorrect. So let me repeat that logic another time. Yeah. All right. If you want to claim that your algorithm is optimal, you have to show that your algorithm beats all the other algorithms, right? Yeah. This is correct. This is not wrong. You have to show that your algorithm beats all other possible algorithms, known or unknown. All other algorithms, known or unknown. Correct. This claim is correct. But the next logic reasoning step is wrong. What's the next one? Because you cannot exhaust all other possible algorithms. How can you show that your algorithm beats all other algorithms? This step is wrong. This logic reasoning step is completely wrong. Why? Let me explain. Even if we cannot exhaust all other possible algorithms, we can still show that our algorithm beats all other algorithms. This is correct. Even if we cannot exhaust, nobody can exhaust. So this is correct. Nobody can exhaust all other possible algorithms for a particular problem. This is correct. But the next statement is wrong. Then you cannot show that your algorithm beats all other possible. This claim is wrong. Why? Now, the key the key explanation part. Why? All right. Derive some key property. So here, let me write a key sentence, key idea. Derive some key property. So that is common for all other possible algorithms. All right, yeah, this is the key step. Why we can do that? Because of this. All right, okay. All right, although we cannot exhaust all other algorithms, okay, yeah, we agree with that, all right, but we can derive some special property. We can derive some special property. This property is true for all other algorithms. All other algorithms, known or unknown, they should all have the same property. We can find that. We can find that, okay? So in our problem 3, this one, problem 3, find the minimum, we did that. We derived some property. Elimination, right? Yeah. Because the minimum, you need to eliminate n minus 1. So this property, all other algorithms, known or unknown, you have to eliminate n minus 1 elements, right? No matter known or unknown. Anyway, in order to find the minimum, you all have to eliminate n minus 1 elements. That property is common for all algorithms, right? Known or unknown. Then we say, because to eliminate n minus 1 elements, you have to do at least n minus 1 comparisons. It's also correct, right? One comparison can only eliminate one element, right? One comparison can only eliminate at the most one. At the most one. That's also correct, right? So then you have to use at least n minus 1 comparisons. So that's correct. So we prove it. So with that observation, here we summarize for a general statement. Although we cannot exhaust all other algorithms for a particular problem, but we can discover some key property that all other algorithms must have it. Then we use this property, we can show that our current algorithm is optimal. That's the deep explanation behind it. If you understand this logic, this whole thing, then you get a better understanding of optimality. How about that? Think about it. So that's the reason I give you these 2 examples. Very useful to help you understand this concept better. Okay, yeah. So here, sometimes, for this example, something pretty common. So actually, in our real world life experience, something like this pretty common. So people give you some logical reasoning. It looks like it's perfect, right? It looks like each step, it sounds no problem. But actually, there is a big hole there. Here, the same thing. So the step looks like, all correct, right? But there is a big hole there. So we find that big hole. So we fix that big hole. Okay? All right. Yeah. That's our video C.4. Now, I have another video to give you another 2 interesting examples. Yeah. All right. So let me stop this one first.